but the series still met all of the publisher's financial goals. Only one of 23 books lost money, and that was just too rarefied a subject for a general audience. And I'm featured in some films. Revolution OS, you can see, I think, on YouTube and Netflix and things like that, and The Code Breakers. I represented open source at the United Nations World Summit on the Information Society, which was a UN meeting in the world's biggest tent, essentially. It was a tent the size of a football stadium. And I founded an organization called No Code International, and this lobbied for the elimination of a Morse code examination for amateur radio operators. It used to be that to get an amateur radio, ham radio license, you would have to learn Morse code, and you took a test on how to listen to Morse code and write down the letters. And I wanted to use amateur radio to teach young people electronics and networking and technology, and not so much the antique side. So it turned out that there was a regulation of the ITU, International Telecommunications Union, that required that all nations teach their radio amateurs Morse code. And this goes back to Morse code being the only common way of speaking to each other that they had. They had a set of 3-letter things that they could all understand in all languages, and they could communicate them in Morse code. Well, that was nice, but mostly we use voice these days. So I got the UN and ITU to change the treaty by lobbying in many nations and getting their amateur radio organizations to ask for this change. Now, this was difficult because many of the radio hams were old guys who said, "We learned, why can't they learn?" Well, we did not want to see amateur radio end in our lifetimes, and the number of people using it was going down. So we fixed that. In the US now, we have more radio amateurs than ever before. Not so in some countries. I don't know how Brazil is. I have 2 companies. Legal engineering is the one that makes money. It assists law firms and their customers with open source and other legal and technical issues. For example, this month I am working on killing a patent where the owner of the patent is suing 20 different companies, and it actually is in filmmaking. It's a patent about synchronizing lips in animation. And I'm also working with a company that they infringed on the open source software. They combined it with their proprietary software without understanding the license. And of course, they did not want to make their proprietary software open source. And I helped them separate the 2 pieces while still having them work together. And then I taught all of the engineers and intellectual property class and how to not get their company in trouble anymore. And I continue to work with that company. I visit them 3 days every month. And it's interesting that I should find my way into helping lawyers, but because I worked with open source licenses, I had to learn this. And then I found that I could pay for all of my open source projects by working with lawyers. Lawyers pay a lot. So I have very much free time when I'm not working with the lawyers, and my family still gets fed, and I get to work on open source. Algoram is my startup company, and it's producing a software-defined radio transceiver. And the reason I needed this is because I've been working on a digital voice codec with a very smart ham radio operator from Australia. His name is David Rowe. And we have an open source voice codec that can reproduce clear voice in only 1200 bits per second. You can almost type that fast. And I figured out my phone has 115 gigabytes storage in it. I could record my voice for the rest of my life and never run out of storage at that rate. So it's very efficient, and it lets us transmit voice over a very narrow voice, very narrow RF channel, radio channel. But I couldn't get any manufacturers to put the codec in their radio. So I decided it was time to have a good programmable radio that would be a platform for software development. And so I am attempting to make it. Hardware is hard to make. I had one design fail. I'm working on my second design. And this will be open source software, and the hardware will be highly disclosed, but it will not be open hardware until I'm finished making that model. And the main reason is that I need to make money back from it, and if I gave everything away at this point, people in China would make it and sell it for less than I did, as they do, for example, with the Arduino. So we have a strategy for being open hardware and also making some money before we are open hardware. So this is the new Brazilian synchrotron light source, and they're using open hardware here. And so the Beam Diagnostics Group has funded and developed 3 open hardware electronic devices in the context of the Sirius electron beam position monitoring and control. And these boards are under an open hardware license. And these measure time to the billionths of a second because they are for particle physics, where the lifetime of a particle is extremely short. And thus they needed very specialized hardware. Well, these are developed in a community. And in my hometown of Berkeley, there is the Lawrence Berkeley Laboratories, where they have done similar development and have shared the designs with their friends in Brazil. And it was interesting when I got here and talked to the nuclear scientists, they all knew the people that I had met at the Lawrence Berkeley Labs in Berkeley, because it's really a small community. There are only a few synchrotrons throughout the world. And so they've shared these designs that were too specialized to get Agilent and Keysight to manufacture them unless they charged really astronomical amounts for them. And of course, the people at the synchrotron knew what they wanted. They had worked out the designs with this community of other synchrotrons. So it was better for them to have this manufactured from their design. And it's open hardware. So now another laboratory, whether they work on nuclear research or something else, can take these designs and duplicate them. They don't have to sign anything. The license already gives permission. And so these will be available in the future. No one can stop you from making one. And they help with the experiments because the scientists can each see if we're making a time mistake. And as you may have heard a couple of years ago, CERN did make a time mistake. And it turned out actually to be a bad cable. So it's very important for other people to audit how you measure time and make sure that you're not making that sort of mistake. So let's talk about the economics of open source, because the biggest question everyone has about open source is, how do you make money? Even if you're in the public laboratory, because all of the public laboratories serve the economies of their sponsor nations. And everyone's sort of used to the Microsoft paradigm, where you you make software and then you sell it and you make your investment back. So most people don't understand how open source works economically. And once you understand the economics of open source, it will help you to use it appropriately, and it will help you to explain it to others so that they allow you to use it. I will give Sarita the slides too. So it doesn't make sense at first, giving away the right to use, copy, and redistribute your software source code or hardware design. How could that make economic sense? But as we see all around us, open source has been tremendously successful, and today millions of profitable businesses and people participate in making it. And to mention just two, Google and eBay, and Amazon, that's three, are built on a base of open source software. And I'll explain why the open source is the base, and then they build things on top of that. But is there some strange, non-intuitive economic principle at work? Well, we have a book in the States called Freakonomics about very strange economics. There are no strange economics. It's just economics, and sometimes people don't see the connections. So the conventional retail software paradigm that a company like Microsoft would use is that they collect investment, millions, $10 million perhaps, to start a small company. And then they work for a few years, and a product is developed, and then sold to users, and hopefully this recovers the investment. And of course, during this time, they may try to go public on the stock market, and thus sell the company at a markup and make them all rich. So this only works for a subset of all desirable products. There were very many products that could never be developed using this commercial paradigm because no one wanted to invest in them, and no one believed that they would be profitable. And for example, the web browser, the actual web browser that was built was very different from the web browser that was invested in. The Xanadu project was a project started by Ted Nelson to develop the web, and it made sense. It made economic sense to the people at the time. They set up a system where you would get a very small payment for every word you wrote. And even when derivative works were made, the payment would move with them. So people who wrote for the web would immediately be paid for their writing. And Autodesk, the CAD, computer-aided design company, bought this project for $10 million and invested much more money. And it came to nothing because the monetary system was too complicated. And then Tim Berners-Lee, who worked for, and I believe still works for CERN, came along and said, I will make a web browser and server, and I will do absolutely nothing about how to make money with it. I will let my users figure out how to make money. So we had an economic boom because everyone had great hopes for the web, and people were paying millions and millions of dollars for domain names, and then an economic crash when reality set in. And through all of this shaking around, we eventually worked out how to make money with the web, and that is how the capitalist system works. Instead of one person figuring out how to make money, everyone goes to work, and we eventually get there. Some people succeed, and the rest fail. And indeed, that's how open source works as well. So why do companies and organizations have software? To support their own operations, not to sell. In fact, 80% of programmers employed today write software that is not intended for sale. I have these figures from the United States Department of Commerce, which studies employment. So a small minority of companies actually sell software. In general, hardware is a tool in a company rather than the main profitable product. So many people have shovels, but only a very few companies sell shovels. Open source is a huge toolbox full of programs for teaching, serving web pages, emailing with customers, writing computer programs, designing integrated circuit chips, and thousands of other tasks. And there are two possible economic benefits from tools. The creator of a software tool might benefit from its sale, as might its retailers and wholesalers. And billions of people and companies can benefit from using the tool, and they can drive millions of businesses by doing so. So tool use is the largest economic impact. Tool use, not sale of the tool. Tools empower people to do some task that they could not do before as well, as easily, or at all. And that task is often part of a business that produces income, and there can be millions of such businesses. So the economic impact of using a tool can be much larger than the economic impact of selling a tool. And tools are wealth. A tool that extends the capabilities of a person is empowerment. And empowerment is wealth, not wealth that you can eat, just as you can't eat a shovel. But the work you do with a shovel or a software tool may indeed feed your family. So when people use open source, open hardware, open source software, they gain useful tools, usually at zero cost for the software, at low cost for the hardware. With open hardware, they get the designs for good tools that can be produced, and that at a low cost because they don't actually have to put profit into the equation in many cases. And this gift can never be taken away. The open source licenses grant a perpetual right to use, modify, copy, and redistribute, give to others, so that anyone can service and extend the software or designs, and new users can always get it. So our first economic lesson from open source is that the users are the most economically important aspect of tools, and that open source is of benefit to the economy because it produces great tools at the lowest possible cost, zero, and makes sure those tools will keep on living, and enables many different companies and people, many aspects of the economy to operate better than they could operate without these tools. So it looks like charity, but most open source developers aren't developing open source as an act of charity, but as part of operating their own business. And so how can a business share their software with all of the world's users without going broke? The fact is that the developers are users too. They need the software to do something important for them, like operating part of their business. But unlike the conventional business model, open source developers share in the development. Many people in many different companies, universities, and also private individuals work together on one program. And by sharing in development, I'm going to talk economically now, they distribute the cost and risk of development so that nobody is giving too much and all the developers benefit. So compare this to the retail software development paradigm where we collect investment, we go to work, a few years later we sell the product. So very front-loaded, costs millions of dollars, done by one small group. The open source paradigm may develop the same sort of software, does not collect money at the start, collects the work of some people, part-time, sometimes at home. They work together, they distribute between themselves the cost of development so no one is putting in too much. and all of the developers benefit. Software is not their product. For most of the companies that are engaged in open source development, their product could be farm produce or automobiles or anything. But most businesses today need software to operate at all. The particular software that open source is useful for is mostly infrastructure or an enabling technology, not the actual product. So a web server, for example, is an enabling technology. You must have a web server to do this. This is a very important point. Most companies have something about them that is a business differentiator. A business differentiator is a feature that is directly visible to the customer and makes that business more desirable to the customer than another. So I say for Coca-Cola, it's the flavor, and they have a secret recipe. For Amazon.com, it used to be their recommendation system. They were the first to have a system that said, if you buy one of Bruce's books, well, people who bought Bruce's book also bought this book, so would you like that too? And that more than doubled their profit because all of the cost of shipping to the customer was in putting the first book in the box and mailing it away. And then when they put the second book in the box, their expenses were correspondingly lower. So when Amazon had the recommendation system as a unique business differentiator, something that made them look directly better to the customer, they could not share this with Bertelsmann and Barnes & Noble. But now, of course, everyone has a recommendation system, so this is no longer differentiating for Amazon. And that's another interesting lesson, is that your business differentiators change over time as other companies catch up. But obviously, companies can't share their business differentiators with their competitor as open source, because if they do, their competitor will catch up with them faster. But they can share everything that they know about operating websites. Coke could share that with Pepsi without sharing their secret formula. And the major effect would be splitting a development cost, lowering the cost and risk of development for each company, and reducing expense. So Coca-Cola has soda sales in their profit center and web servers in their cost center. So what we're doing here is reducing a cost center expense so that we have more money to spend on our profit center. So what if you are a startup company? What do you do to succeed better with open source? You take everything that you need to do that you can get from open source and do it with open source or develop it in a community. Then you take your business differentiator and you spend all of your software development money on that, and no money on, less money on things like web servers and websites, etc., because you can get all the infrastructure for that from the community. So open source provides a method to move your software budget into the things that actually make a difference to the customer. Now, you can make a mistake in what makes the difference. For example, do you remember BlackBerry telephones? Okay, BlackBerry, after iPhone came out, BlackBerry bought an operating system company that made something called QNX Nucleus. And they decided that the BlackBerry phone would be the most reliable because QNX Nucleus was an ultra-reliable operating system used to manage nuclear reactors. And they built this into their system, And all of the customers looked at it and said, well, great, it doesn't crash as often, but it doesn't run the apps that I want to run. So BlackBerry lost because they chose the wrong differentiator. So you must look very carefully at what is important to customers, and you must not have not invented here syndrome. Not invented here syndrome is the belief that we are smarter than everyone else and we can do things better than everyone else. You must be open to other ways of doing things from other people who are just as smart as you, even if they come from another nation. And that way you get what you can from them in open source and concentrate on what is most important. And I have a way for you to learn about this, which I do. I go stand in the Apple store. And of course, Apple uses open source, but Apple isn't about open source. They're about their proprietary software. And I stand in that Apple store and look around at how happy and excited the people are, because what they see from Apple is that they're getting a tool which is powerful and will enable them. They don't see the dark side of Apple, which is that Apple will only allow you to choose the tools that Apple approves of, and Apple will know everything about you. But that's for another talk. And so go and do that, and you can get some intuition to what is actually important to customers. And you will never hear a customer in that store saying, what is your operating system's kernel? That is infrastructure that they don't care about. And that's why I tell companies, use Linux, don't develop your own kernel, because Linux is free and the customers don't care. So the way our communities work is that project leadership is by technical meritocracy. It is not by the marketing department. It has no power to force, only to persuade. And if any one company tried to force its agenda on others, the others would not cooperate. And surprisingly, we get a lot done that way. It turns out that putting the engineers in charge builds a better partnership than having the project directed by marketing or management. And that's because the engineers share a common goal of making great software, while marketing and management often contaminate the partnership with their competitive aspirations. And my favorite example is the X Windows system was a consortium. They had pay for say, in that you paid $100,000 and you got to sit on the board for a year and have your marketing people say what the engineers would make. So one day, the X Window Consortium board decided that they would not make a canonical user interface toolkit. They would not make the buttons and dials be the same across all of the Unix workstations, and they would not have the API be the same. And this was so that Apollo and HP and IBM could separately lock their customers into the API. And Microsoft was part of this board and must have been laughing into their sleeves, because Microsoft would go on to make a common user interface toolkit for all manufacturers. And that was the day that Microsoft killed Unix in the market. It was that marketing decision that caused it to happen. And if we put the engineers in charge, of course the engineers would have made a canonical user interface toolkit for everyone, and Unix would have been in a better shape. Well, we had to fix that. You know, engineers like me were very angry because, frankly, we didn't like Microsoft Windows, especially 3.1. It wasn't very good. I worked for Steve Jobs, and Steve said, well, Windows is taking over. This is, of course, between when Steve was at Apple. He had Next Workstation for a while, and then he had his office at Pixar, and then he was back with Apple again. So Steve said Windows was taking over, and I hated it so much, and thousands of other people hated it so much that we made Linux really good. And so we sort of turned things around with the community effort. So forking is a very interesting power within open source. Forking is the right to take a project and split it off and take it in a different direction from the original developers without their consent. And people used to think this was actually a very bad thing about open source, but it turns out to be almost magical in its power. And we should call it the right to avoid bad management, because that's what it's often used for. If other developers like your fork of the project, they'll come over to it and work with you, and your version will prosper. And if not, only your work will be wasted, not that of the entire team. And in some cases, all of the developers of a project have forked away from one bad manager. This was the case with a later instantiation of the X Windows system called X386. We had a manager who wasn't going the direction that the engineers wanted to go, and the engineers all walked off and formed X.org, and that project flourished and the old leader was forgotten, and that is technical meritocracy. So this is, I hope this works in Portuguese. The marketing paradigm of open source is a massively parallel drunkard's walk filtered by a Darwinistic process. So what does that mean? A massively parallel drunkard's walk means everyone does what they want to do. Everyone works on their own software idea, and then everyone puts their software idea out on the internet and says, hello world, here's my software idea. If you like it, let's form a community. And some of the projects form communities, and some of them die on the vine, wasting only one person's work. So the good ideas and good leaders develop those communities, their projects expand, and people with different ideas of how their project should go can always pursue them and build their community. So this actually gets us in directions that perhaps a marketer might not have gotten us in a conventional company, because much as they would like you to think they can fathom the future, marketing has no crystal ball, and they often make bad decisions. And critical to this is the control that open source gives you, because you have the source code and the right to change it, and you're not locked into someone else's agenda. So in contrast, nobody can deny the role of Apple in today's world, but we should know one startling sign that their proprietary software is failing, and that is both Apple and Google spent more on litigation. In Google's case defense, this was in, I believe, 2012, when I was actually working on Google's defense in Oracle versus Google. And they spent more on lawyers and expert witnesses like myself than on all research and development. And what does this tell us? It tells us that our grip on intellectual property is ultimately bad for the production of real usable goods for people. Unless you like making lawyers rich. And, you know, I've profited off of this because the rest of the world, for me, isn't open source. And, you know, it's nice sometimes to take some money from that and put it back into open source. But I would happily give up all this intellectual property work if people just treated more things as open source. So we have a new economic paradigm for producing excellent software that everyone can use. And it's all around us, and now it goes to hardware. So open hardware is the design of a physical object or an electronic circuit that is shared under the same terms as open source software. And the objective is to have the same sort of collaboration that occurs with open source software. Well, it turns out that copyright does not necessarily work as well for hardware as it does for software. And this varies between countries. For example, here in Brazil, you have a moral right of the author system, similar to the United States copyright, where it is the author who is most important. In the United States and England, we have a copyright system where the work is most important. And it turns out that copyright in the United States is weaker for hardware designs. Hardware designs there, and to some extent here, are the domain of patent rather than copyright. So we have various open hardware designs which you're familiar of. The Arduino is a very inexpensive computer, very easily programmable for artists, students, and other projects. I just bought 5 for $20 US on eBay. So they're now very cheap, and I can just put a computer in something the way I would have put a resistor a few years ago. And the magical thing about Arduino is that it has shields, these hardware boards that you plug into it that do many different applications. So this particular one goes in my car and tells the other amateur radio operators where I am. And it's very funny. I'll be sitting in McDonald's and another ham will pop in there and say, I saw you in the neighborhood. Why the Arduino? It has a community. It's 100% free software, including its hardware design. Once you've used it in your development, you can take the AVR CPU that it's based on and use it as a part on your own printed circuit board. And at that point, it only costs $1 to add in. But it's only good for small projects. For larger ones, we use a full Linux system. The Raspberry Pi is very popular, but it's not fully open. It has proprietary boot and graphics code, undocumented coprocessors, but still very popular for a lot of open source projects. We have other interesting things. Someone made, one guy made this little handheld oscilloscope, which is very popular these days. This is one of my favorite. It's called the Bus Pirate. It lets you hook into any computer bus and understand it and direct it, and it costs $30 US. And so if you are a manufacturer and you think, I can't see that you've used open source in your product, I can take this and I can see everything about the insides of your product with it. And of course, I can use it also to design new things because it provides you with a way of driving buses immediately. So you may immediately connect it up to parts and make them do things. And it has very many different protocols for using over those buses. This is for development of complex logic, both analog and digital. Makes it very cheap. For gate arrays, $50 gate array development board. And this is one of my favorites. It's a open hardware, so you can take the design and make your own if you wish. Thermal cycler for the polymerase chain reaction. So you can work on engineering DNA with this device. It gives me a little shiver that people are doing genetic engineering at home. And of course, now they have CRISPR, so they can do very powerful things with that genetic engineering. So like open source software and Linux, there are enabling factors that make this revolution possible. For Linux and open source, the internet was an enabling factor because it allowed us to have a worldwide community, where before we all had to be pen pals. The frustration with the state of software was an enabling factor. The fact that many engineers like me didn't like Windows. The extremely low point of entry to be able to produce software. You just need a laptop and the GCC compiler, and you can go to work. And we don't even charge you for the GCC compiler. So let's consider the impact of the internet. I'm going to say some things, think about them as if it were 15 years ago. My friends and I are going to get together and write an encyclopedia. The authors aren't going to be paid, but we'll write 3,422,000 articles just in English, more in Portuguese. And we're going to kill Microsoft and Carta and Encyclopedia Britannica in England and most commercial encyclopedias that have been going for 200 years and made tons of money. Everyone who wanted their kid to go to college bought one, and no more for those things. Encyclopedia Britannica doesn't even print anymore. It's only online. And so what would the response of most people have been had I said that to them just 15 years ago? They could not imagine such a thing as Wikipedia. So imagine telling someone this: 2 students' hobby projects will supplant the operating system and graphical user interface efforts of AT&T, IBM, and the billion-dollar consortia of the massed computer manufacturers. They had one called Taligent and one called Monterey, and these were to rewrite Unix so that it would be better than Linux, and they got nowhere. And they had big buildings and everything, and they worked for 2 years, and then they gave up. But if I had said this to someone 15 years ago, they'd say, are you using C++ or LSD? So much of the evolution of open source is filled with things that would have been thought to be impossible a few years before they had happened. And thus this is an emergent phenomenon. No one, with the possible exception of Richard Stallman, thought that it would take place until it was already underway. So we should look at the factors that combine to produce it and then look forward. So it used to be that when strange things happened, the news would report, police believe these are the actions of an isolated crazy person. There are no isolated crazy people in the age of the internet. Whatever kind of crazy person you are, there are 100 crazy people just like you. And when you can all meet on the internet. And when you have 100 people with the same crazy idea and some spare time, you have more creative power than the typical startup company. Goodbye, venture capitalists. We don't need you anymore. Well, for some things we still do, but not for open source. So in the case of open source and Linux, we saw the rise of online communities that wanted to get something done. We saw the creation of this economic paradigm of open source that allowed us to share while still making money with our business differentiators. And this was very different from the way that companies typically created projects. So the way this started was that motivated individuals, for example, Richard Stallman created GCC, the compiler, and Emacs, the editor, as some of the tools to make the tools, okay? These were tools that everyone else would use. So Linus Torvalds came along and used GCC to compile the Linux operating system's kernel. So you see we had tools to make the tools, and these things go on. So broader development grows from those seeds. And we had a multiplier effect as the ecosystem develops. As we make more tools, we can make more things. More people get involved. People see, hey, Google made billions of dollars. Maybe I don't understand something about this open source, and they get involved. Okay, and it is happening again. Now we're in the same place that we were when Linux and open source software were starting up, but for hardware. And in the case of hardware, we have another set of enabling factors. Start with all of the enabling factors for open source software and internet to bring us together. The economic paradigm we created for open source, the software tool collection, which we will use for the development, and everything that we've learned about collaboration, and the transformation of hardware into software. Okay, so hardware is software now. So 3D printers make it possible to print solid objects the way we used to print photographs. But if you have this extruder 3D printer, it's not very good. Okay, my standard for quality is that before it's good, you must be able to print a well-working Lego block. Okay, if you can make a well-working Lego block, you can make many other kinds of parts. And it turns out that Lego actually has very high standards. The engineering for fitting the blocks together and having a very specific insertion and removal force that's good for a child, and that the thing won't fall apart when they've made it and frustrate them. That's actually very careful engineering and specification. So we now have ultraviolet lithography. This is the second generation of 3D printers, which uses light rays to harden plastic. And thus, this is much more accurate than the extruder version. And for example, my son is having his teeth straightened, and they are doing it with 3D printed parts that he wears in his mouth when he's not eating. And they're clear, so people don't see them. And the gate array is a platform for us to develop immediately run, create and immediately run very complex digital logic, and it runs faster than a program in a CPU because it all runs in parallel. And there's no need for the tremendous infrastructure that we needed to make an integrated circuit before the gate array. When we made an integrated circuit in the 80s at Pixar, we designed it for half a year, we sent it away, and we got it back in 2 months. And it had better work because we could not wait another 2 months if we made a mistake. Now, you type in your design and it runs immediately, and if there's a bug, you can fix it immediately. So very big change, and these gate arrays are cheap. We also have complex programmable logic devices, which are the equivalent for analog, and the tremendous power of today's CPUs allows digital signal processing to replace the analog electronics of the past. Thus, I am working on software-defined radio, where we digitize the entire radio spectrum, for example, from 0 to 30 megahertz. We digitize that in one piece, and then we can separate one station out with the fast Fourier transform. Many fewer analog components and higher quality than we could achieve in analog. We also have cheap and fast manufacturing of printed circuit boards. So I have, for example, sponsored the development of a 700-part printed circuit board personally. And it cost about $5,000 US prototype. So let's get to science. Duplication is a key part of the scientific method. If another lab can't duplicate your experiment and get the same results, it's not science, and you will have to withdraw your result. And we've seen, for example, the Italians made a forecast about some atomic particles, and no one could duplicate it, and they took it back. They don't know if they made a mistake or not, but when you can't duplicate the result, you can't really say that it's science. It's also necessary that we give a very detailed description of our experiment so that if we get something wrong, another scientist can show our mistake even long after our experiment is done. So we get back to open source and open hardware because they enable another researcher to exactly duplicate the tools that I used in my experiment. If I use open source and open hardware, I can directly give that researcher the source code. I can give them the hardware design, the files used to print the circuit boards. For example, the timing system used by the Brazilian synchrotron and also used by Lawrence Berkeley Labs. Now, a good researcher will use this information to understand the other laboratory, but might develop his or her own tools and a different path of investigation, and that is to check for bugs. We don't want to have the same bug fooling two different laboratories, but we do want to have both laboratories understanding exactly what the other did, and once they have confidence in the tools, sharing the tools among themselves, because that lets them get to the work instead of spending more time making tools. So as I showed, the Brazil lab and the lab next door to me in Berkeley make the same equipment. And they could have shot this out, say, to Agilent or Keysight. But if they did, when I worked for Hewlett-Packard, we made 5 times the cost of fabrication on the margin of our test equipment, for example, spectrum analyzers. And that was because it had a rarefied market. We would not sell very many of them, so we had to recover the cost of development. Now, for the nuclear laboratories, you only have 7 customers. So the margin would be 20 times, perhaps. Well, the laboratories don't necessarily want that. They can do this by themselves, and they're actually more comfortable to do so. But when they specify things to be manufactured and designed outside, these days CERN specifies designs must be under the open hardware license because they pay for the design and they want the design rights back. And thus, everyone could use these designs, but they will probably go to the same person who made them because they're already set up for manufacturing them. In the US, we have the International Trafficking in Arms Regulations, and this does not only govern distribution of AR-15s, it governs rocketry and satellites and digital voice compression like that which I work on, nuclear research tools, and I also volunteer for AMSAT, which is the Amateur Radio Satellite Program. And how would AMSAT or my digital voice project cooperate across nations? Because I'm working with an Australian amateur. In the case of AMSAT, we work very extensively with the Germans. And in ITAR, they did not do this out of kindness. They did it because we sued them. There is a carve-out for information that is in the public domain. So if you put your information out to the public, ITAR does not restrict its transfer to other nations. So projects like the open quadcopters, they have an open pilot software. that is put in open source because they could not share their development with the community across countries otherwise, because of course if it can fly a quadcopter, it can probably do a missile also. So the military would be a little worried about that. And as long as AMSAT makes its development open source and open hardware and publishes it as soon as they work on it, they can share it across other countries. And this applies to your laboratory as well. Now we're getting to the end of the speech. We get to technology transfer, which is how we as laboratories transfer our technology to the public. And of course, in the United States, we have an awful method of doing this, which is we patent everything, and we sell the patents perhaps to the highest bidder, perhaps to a company that's affiliated with one of the researchers, so they're already in bed together. And then that company has a monopoly on the invention, which is paid for with public funds. And it may be that you, as a taxpayer, pay public funds to make an invention, and you have a company, and your company is sued by the owner of the patent for an invention that you actually paid to develop. So there's some injustice fundamentally in this at times. But the company may not develop the patented technology after paying for it. They may have bought it to slow down other companies. Or they may fail. So the monopoly patent transfer model is necessary when there's a high cost of investment necessary to productize the invention, and thus a higher return on investment is also necessary. So for example, with a drug, this might be the case. It might cost billions of dollars to develop the drug, and then in the States to get the government to actually approve the drug takes very extensive testing, which itself might cost billions of dollars before we will allow it, because we still remember thalidomide in the United States, which took off the arms of children. So for other sorts of inventions, though, where the cost of development of a product is low, the monopoly patent model is inefficient. Because software development, you just need a laptop. You don't need $1 billion investment. So, in general, failure of any new product development, either technically or within the market, is more likely than not, especially if you give it to only one company. So what if you gave it to 1,000 companies rather than one, and you didn't charge them anything? You gave it to the whole world. It is much more likely that one will succeed in implementing use of the invention than if you gave it to only one company. And thus, your end result, which is benefiting people as a public organization, is better fulfilled by taking your inventions and publicly disclosing them, putting them out in open source, if it is economically possible for people to develop them as products at low expense, not at high expense. Then you can use the patent the monopoly holder. Are we kidding ourselves about our patents? Okay, the only way to enforce the monopoly right granted in a patent is to bring lawsuits. And engineers are instructed, every company I work with, don't look at patents, because it actually helps to get your company sued if you look at that. And it can cost a company $10 million US to defend themselves in a patent lawsuit and win. Okay, if you spend $10 million to win, is that really winning? No, it is not. You may have bankrupted your company on the way. there's really no justice here, especially for the little guy. The little guy cannot afford to be in this case and has to settle with the patent holder for whatever terms they like. Now, my own expert witness business will charge a tremendous amount of money on this. The lawyers charge twice as much as I do. So you will be spending more than $1,000 for every hour that you were in the court. Now, I submit that the patents produced by publicly funded research are today used more to impede the development and utilization of technology and feed attorneys and experts than they are actually used to put technology in the